Let's go through equal 2,536 increase submatrix by 1. So it gives us an n multiple by n matrix and also a two-dimensional array query. For each query, it will increase. Each query it has four numbers, which will represent the top left cell and the right hand cell. And of a rectangle, it will increase all of the number in this rectangle by 1. And after, for example, this kind of queries, uh, we want to find for this matrix what's the final numbers or states, final numbers in each cell. So for example, first time we increase this, right? And then second query we increase this. So 1, 1, 1, this is already 1, this will be 2, right? So this will be the result 1, 1, 0, 1, 2, 1, and 0, 1, 1. So how can you do these questions? Apparently, what we're thinking about is that we cannot, for every query, trying to increase all of the numbers in the rectangle. Because for every query, if we do an increase of the rectangle, right? The query, it will be an n square in for each query to increase that, right? And multiply query, that will be a huge. Let's look at the time complexity. It will be 2 multiplied by 10 to the fourth and multiplied by 10 to the power fourth will be um TRE, right? So we cannot do brute force. So how can we do better? First thing is that we can think about the diff arrays, right? So for we thinking about if we can, but we know in one dimensional array, the diff array is very easy. We add at the left index and -1 at the right index +1, right? So for one dimensional, it is very easy. But for two dimensional, the diff array is a bit complicated. So we have two strategies. One is that for every query, we we convert these queries to the diff array for every row, right? So for example, we have um, row 0, column 0, this query, and then row 1, column 1, right? So we can from row 0 to row 1, and for every column 0 plus 1 and a column 1 plus 1 minus 1, right? So we just have a diff array for each uh, for the rows of each query, right? So in the end, what we do is that for our final result, we just trying to see for each row, we just use a diff array to get the final result. So we can write the first approach, convert the queries, each query to diff array in its row, right? So let's write code for this. Um, so we're going to have two-dimensional array result equals new int n, right? So we for every query we're going to have so what we do is that for we need to have every row, right? For row equals query 0 and the row small equal to query 1, right? And the row query 2, sorry. query to row plus plus. Then we have mm, let's say every for this row we have a row column equals result row, right? Then we're going to have result query Q1 to the path equals 1, right? So if result if Q3 plus 1 is smaller than n, then we're going to have a result row Q3 plus 1 minus equal to 1, right? And then for every row in this matrix result we have we do for each row the differ rate to find its final result, right? So what we do is that for every into row equals 0, row smaller than n, row plus 1. And for every into column equals 1, column smaller than n, column plus. So I'm going to have result row column should plus equal to row result row column minus 1, right? And in the end, return result. So this is the way we convert the two-dimensional diff array into one-dimensional diff array. It will not be very good for the runtime. Um, let's also write a Python code for this. Um, so we're going to have result equals for underscore in range in right. Then for Q in queries, we know row 0, row 1, column 0, row 1, column 1 equals Q, right? For every row in range, row 0 to row 1 plus 1, then we're going to have if we see column 1 plus 1 is smaller than, and let's say we are at a result row column row C0 plus equal to 1, right? And also we have result row C1 plus 1 to the minus equal to 1, right? Then what we do is for every row in range, and we're going to have for column in range, and we'll have result row column plus equal to row result row column minus 1. So in the end, the return result um, every row C0 plus 1 equals C1 minus equal to 1. Column row column 0 plus equal to in row column 1 plus 1 minus row column minus 1. What's the problem here? Actually, we should have column from 1 to n, right? Because otherwise we are going to have the last one added to our row 0, right? That will have problem. So we'll see, let's say analysis time complexity here. We'll see this has Q, right? For each Q, and we have every row do some kind of O1 operations to add that to the diff array beginning and minus one at the diff array end, right? So this Q is an OQ minus O row, right? Row is an time complexity here. And here that is an n squared time complexity. So I say this part, well, but let's look at the time range because the Q has the 10 to the power fourth time complexity. So we convert the diff array for each row. Apparently, um, this part, the first part, will take some time, right? So if we can do the diff array in two-dimensional, it will apparently better, will have better time complexity, right? So we also let's write also write that diff array in a matrix. So how can we write a diff array in matrix? So to write a diff array in matrix, it is also the concept is it is simple, and we have row 0 column 0, and row 1 column 0, and row 0 column 1, right? And row 1 column 1. So at this cell, we're going to add 1, and at this cell to the its right, we're going to minus 1. And at this cell to its below, we are going to minus 1. Of course, we need to make sure they are not being out of bound. And at this cell, let's see, the row and column, we are going to plus 1, right? So why this is minus 1, right? Because for this part in the middle, we are going to add 1, right? So in the final result, we are going to add from the row plus 1 will add equal to for example row I minus 1 plus 1, right? Row I minus 1 column for each row column, and also for each row column I will add its left that row column I minus 1, right? So the diff array is that we make sure we add this one to be plus 1, and this is minus 1. This is minus 1, and this is the plus 1, right? So let's write code for this one. We're going to have int result equals new int n, right? So for every query Q in queries, so we know let's have int row 0 equals q0, and column 0 equals q1, and row 1 equals Q2, and the column 2, column 1 equals Q3, right? So we'll say result row 0, um, column 0. We should at this one we should add a plus 1, right? So we'll say we're going to have if column 1 is smaller than column 1 plus 1 smaller than n, right? Then we're going to have result row 0, column 1 plus 1. You should have minus equal to 1, right? And then also we have if row 1 plus 1 is smaller than n, we're going to have result row 1 plus 1 and column 0, we should minus equal to 1, right? And also we should make sure the result row 1 plus 1, column 1 plus 1 should plus equal to 1, right? So this is a diff array for a matrix. So what we do is that for int row equals 0, row smaller than n, row plus plus, we're going to have also we need for int column equals 1, column smaller than n, column plus plus. So we're going to have result row column should plus equal to result row column minus 1, right? And also this is for every row, right? And also we need to do for every column into column equals 0, column smaller than n, column plus plus, right? So what we do is for every row equals 1, row smaller than n, row plus plus. We can have result row column to the plus equal to result row minus 1 column, right? And then in the end, it return result. So here we also need to make sure the column, right? If row 1 plus 1 smaller than n, and the column 1 plus 1 smaller than n, right? Then we're going to have this one. So we'll see this is much faster. The reason is that we'll see we just iterate the Q loop, right? For this query loop, and all of we just do this kind of operation. They are constant. So this is just the OQ operation above, right? And also here, this is the O row multiplied by column. This is a row multiplied by column. So this will be a Q plus N squared time complexity, right? So previously, when we use the diff array in each row, that will be NQ multiplied by row, right? And then plus M plus N plus N squared, right? But here that is only OQ here. We can also write a Python code for this. We can have result equals multiple by n underscore in range, right? Then what we do is that for Q in queries, we're going to have row zero, row column zero, row one, column one equals Q. So we'll have result row zero, column zero to the plus equal to one, right? So if column one is smaller than column one plus one, right, is smaller than n, we're going to have result row zero, column one plus one to the minus equal to one. And if column one plus one is smaller than n, then have result if row one plus one smaller than result row one plus one and column zero, we should minus equal to one, right? So we'll see if row one plus one smaller than n and column one plus one smaller than n, then we'll have result row one plus one, column one plus one, we should add equal to one, right? Then we do for from top to bottom, and then from right to left, right? So what we do is for um, row in range n, for column in range from 1 to n, right? Because now it's the we add every number from its left, right? So we are going to have a result row column should plus equal to result row column minus one, right? And also then we need to for row in range from 1 to n and for column in range n, right? So every result row column we should add its top values, right? Should add equal to result row minus one column. So in the end, the return result